Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
Hello dear students, welcome to part 7 of the topic Thermodynamics. We shall be continuing from what we did in part 6. So, I highly recommend that you go through part 6 first before you go ahead with part 7, because that is where we have introduced the concept of enthalpy on which we are going to build today. And today the lesson is going to be short and sweet because we are not introducing any new thermodynamic quantity today. Building up or taking up from where we left, U2 plus PV2 minus U1 plus PV1 is QP is what we had reduced yesterday. Rearranging them, we get U2 minus U1 plus PV2 minus PV1 is equals to QP, that is the amount of heat absorbed or evolved at constant pressure, where we had introduced also the concept of H, that is enthalpy. So now we have first equation from the first law of thermodynamics, delta U is equals to Q plus W. Delta U is also equal to QV we had derived. Delta H is equals to QP. Delta H is the change in enthalpy, change in internal energy. Picking up from here, U2 minus U1. Now U2 minus U1 is change in internal energy. Plus P, V2 minus V1 denotes the change in volume. So we have another equation over here, delta U plus P delta V is equals to QP. Now we also know that QP is equals to delta H that we had derived yesterday. So we can say delta H is equals to delta U plus P delta V. This is nothing but another form of the first law of thermodynamics, meaning to say the change in enthalpy of a system at constant pressure is the sum total of the pressure volume work done and the change in internal energy. P delta V, PV. Does it ring a bell anywhere for you? PV is equals to nRT. If you remember, this is our ideal gas equation. PV is equals to nRT. That means PV1 is equals to N1 RT. We are talking about a process which is taking place at constant pressure. So PV2 is N2 RT. Subtracting equation 1 from equation 2. What do we get? PV2 minus PV1 is equals to N2 RT minus N1 RT, which brings us down to PV2 minus V1, N2 minus N1 RT. Isothermal process at constant pressure. P delta V is delta nRT. Now, if you notice over here, I put a small g as a subscript. What does this subscript denote? We are talking about gaseous reactants and products. Why? Why are we not taking the solids and liquids into consideration? In the case of solids and liquids, what happens is the interaction in the case of solids usually takes place on the surface, whereas the liquids react in the solution form. So, it is the gases whose volume changes tremendously when you are carrying out the process under any conditions other than isochoric. So what we will consider over here is it is the number of moles of the gaseous reactants and products which are to be taken into consideration. More so, this equation is ideal gas equation. We have to keep that in mind. So, the above equation can also be rewritten as delta U is plus delta NGRT equals delta H. So, this is nothing but another form of the first law of thermodynamics. In part 6, we had proved that delta U is equals to QV and delta H is the same as QP. the amount of heat absorbed or evolved at constant volume is a measure of the change in internal energy, whereas the amount of heat absorbed or evolved at constant pressure is the change in enthalpy. Now, so we can also write the equation as QV plus delta NGRT is equals to QP. Under what conditions can our delta H become equal to delta U or QP become equal to QV? Very, very simple. If for any reason this value, that is delta NGRT, becomes 0, we will have delta H equals to delta U. Now, when will this become 0? Of course, R cannot be 0. T cannot be 0 because not all reactions will take place at 0 degrees Celsius. And anyway, we are talking about absolute temperature over here. So, minus 273 degrees Celsius. So, what are we left with over here? Delta Ng. When can this delta Ng be 0? Two possibilities. One is, of course, you don't have any gaseous reactants during the course of the reaction. There are no gases involved. The second possibility is when the number of gaseous reactants is equals to the number of gaseous products. For example, let us say I'm talking about a reaction H2 plus Cl2 gives me 2HCl. Now all these reactants are gases. We have 1 plus 1, that is 2 moles of gaseous reactants and 2 moles of gaseous products. So 2 minus 2 becomes a 0. So when the number of moles of gaseous reactants is equals to the number of moles of gaseous products, then in that case your delta Ng becomes 0. So, two possibilities are 1 and 2. There's another third possibility. Come back to delta U plus P delta V is equals to delta H. Try and recall when can work done be 0. Yes, when there is no change in the volume, delta V is equals to 0. In such circumstance also, delta H becomes equal to delta U. Now, when is delta V equal to 0? When there is no change in volume, the process is being carried out under isochoric conditions. You are carrying out the process in a sealed vessel so that there is no change in volume. Under enthalpy, please remember that enthalpy of elements or substances in their elemental state like nitrogen, oxygen, hydrogen is taken as 0 as a standard. In part 8, we shall be introducing some new thermodynamic quantities again. So we shall be talking about entropy. Before that, I would request you to go through this concept and try attempting numericals. Let me know if you have any doubts in the numericals. We shall have a separate lesson based on how to handle numericals. Happy studying.
The only mission of this channel is to make learning chemistry easy and fun for all you students. With the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals. And this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel. There is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.